so here's the lab session, and in the lab session, we are going to read. I'm just going to do my own homework assignment, and starting from scratch. So I'm not going to even make any assumptions of, oh, we got all of these files already created. All right, so I'm going to use a text window to do most of the work. So the first thing I have to do is to create the necessary files. The first one, so create a folder called mastermind. Go to the mastermind folder, create mm.h first, and for the most part, we can just kind of copy and paste. So copy and paste. Do Control D at the end. Sorry?
How do you copy and paste under there?
Since I'm using Linux, it's just the middle click of a mouse will do it. If you are using PuTTY, I believe right click will do it. Huh? No. You have to use PuTTY.
Oh, okay.
Yeah. So instead of using the console of the virtual machine, you have to use PuTTY to connect to the virtual machine. Which I think I think I illustrated that at the beginning of the class. Yep.
Usually like Control Shift B would do it too.
Okay. So inside QEMU, that would do it too.
That's how I do it in Linux.
Okay, cool. So that's the first file. The second file that I need to copy and paste would be main itself. So do a copy from here, cat to main, type today, and do a paste. I had one extra click. There we go. So we have mm.h and main.cpp. And then the last file that I'm going to use is makefile because it's just saves so much trouble. I'm going to use it. So I'll save it into mastermind. Oh, I see. So I think I just put it in the wrong place. Okay, fine. I'm gonna. Oh. This one is already modified for the current homework assignment, so I'm just going to have to remove the last entry to make it work with the previous homework assignment. So now I got the header file and main.cpp, and the main job or the main thing I have to do is to implement the subroutines in mm.cpp. So what I'll do is I'm going to make this screen as large as possible so I can display things side by side, and I'll stretch it down as much as I can. And the people in the back, can you guys still read the entire screen? Okay, all right. So we'll do a make, not vim. We'll do a vim mm.h on one side and mm.cpp on the other side. So this way I can look at the header file so I can see, okay, what do I need to implement and the prototype and stuff like that. So I will implement everything from scratch, including mmRead. Okay. And the way to do it is just to do it in a loop. What we need to do is to read an integer into pattern as an array of integers, which is a member of a structure called a guess. Okay. So in order to do that, I'm going to use I as an integer, as an index. As long as I is less than, now I could have just said 4 here, okay? But that would not be safe because I said it's fixed. In the homework assignment, I said that I could give you a different mm.h file and your code is still supposed to work. So you have to use pattern length here, okay? Because if you don't do that, your program will break when I use a different header file, okay? So for each position, I'm going to read an integer. Since error checking is not required for this homework assignment, you can just go ahead and do a scanf.
Oh, it's not?
It's not.
Okay.
You can do error correction too, but since I won't give you any error conditions, so that part of the code will not be exercised. So sorry?
What file are you working in right now?
You can tell from here. Yep. And I'll be reading into something. Okay, this is the part where I start a new line. When I do something like this, you know what is going to be specified here is going to be long. Okay. Now, when you type code like this, I would not do it sequentially the first time. In other words, I would not try to think out everything and just type it from left to right, because this is relatively complex. So I would just do it step by step. The only thing I can start with is either I as a local variable or the parameter PG. In this case, I have to start with PG because I cannot even get to the array until I get to the array. I is useless because I is an index into the array. So I'm going to start with PG. Okay. PG itself is a pointer to a guess structure, which is good. Okay, it's a good starting point. But I don't need this pointer. I need the structure pointed to by PG. So that's why I need to first do a dereference. Now, since I am not going to require you to remember the priority of all these operators, I'm just going to use extra parentheses to indicate what is done first. So what I have now is dereferencing the pointer, which means I have a structure, which is a guess structure. Within the guess structure, there's only one array that I need to do something about, which is pattern. Okay? To access a particular member of a structure, I use the dot notation. So I'm going to use a PG with asterisk before that in parentheses and then a dot pattern. Once I get to the pattern, I can now use the indexing operator, which is the square brackets. So I can now say, I'm not going to store into just any element. The element or the index of the element is controlled by local variable I. But scanf doesn't want an integer. Scanf wants the address of an integer. So that means I have to take the address off. So when you take the address off, I'm just going to use extra but unnecessary parentheses to indicate that I'm taking the address of not pattern, not the structure, but a particular member of pattern, which is a member of the structure pointed to by PG. Are there any questions about how this particular expression was formed? Or about the order of thinking, how I think about this problem, starting with just PG. Questions? All right, so just a single scanf should do it. This is mmRead. Are there any questions about mmRead?
Do you have an extra parentheses there?
I think I got all the parentheses matched. Nope, they're all good. That's why I like VI, because it automatically matches the open and close parentheses.
I wasn't looking at the line before.
Oh, okay. Yeah, I had to break it into 2 lines, otherwise it will do the wraparound thing and make it even harder to read. Okay, that's mmRead. The next one is print score. That's an easy one, so I'm going to do that first. Print score. It will take a const struct guess PG. The const simply means I'm not going to change anything in the structure itself, which does not interfere with what you need to do with this particular subroutine. And to do this, I just need to print 2 numbers. There are several ways to do it. If you want to separate it into 2 different printfs, that's good. If you want to combine them into 1 single printf, that's good as well. Okay, so this is entirely up to you. Because what you can do is to do something like this. Okay, so when the format string is %d and \n and %d \n, it means you are going to print an integer, a line feed, another integer, and another line feed. We can break it up into 2 or even 4 printfs if you want to, but this is just combining everything into 1 single printf. The first thing I'm going to print is the number of black pegs. Okay, so eventually I want to get to score black pegs. This is the other way to approach the problem. Okay, this is a member of a structure. Okay, so that means I definitely need to put this dot here because it is a member of a structure. But what structure are we talking about? Well, we are given not a structure, we're given a pointer to a structure. So what we need to do about the pointer is to dereference it first so it becomes an actual structure. So that's the other way to think about what expression you need to specify when you're accessing something that is not straight, that is not easy to figure out. So one way is to start with the pointer itself and work your way to the exact thing that you need to access. The other one is to get to the end, which is what you need to access, and then figure out your way back to connect it back to the parameter. Are there any questions at this point? Okay. If there are no questions about this, we'll just go ahead and copy this line, because the next one that we need to print is the number of white pigs. So we just change a few things like that, close the parentheses, and that's it. Okay, print score is that. Are there any questions about read or print score? Okay, now we move on to the most complicated subroutine of this homework assignment, which is score. Score has two parameters. The first one is an array hidden, and the second one is a pointer to a structure, to a guess structure. Okay, so
Misspelled hidden in the prototype.
say again?
You misspelled hidden in
Oh.
the prototype.
Oh, hidden. Those are, as much as I don't want to downplay my own typing mistakes, this is not a big problem because the compiler will easily catch that. Anything that the compiler can catch is not a big problem. Things that cannot be caught by the compiler, bigger problems. Because they become runtime issues. Okay, but thanks for pointing that out. Okay. All right, so the way we do it, there are several ways to do it. So what I would do is I'm going to declare two different arrays to remember what pegs of which pattern is already matched. Okay, that's how I'm going to do it. So I will define, without any consideration of saving space or anything like that. I'm just going to say, int hidden marked or marked, whatever you want to do it, matched. Okay, there we go. Hidden matched, and we'll make the array the same size as a pattern. So you have to refer to pattern length here. And then the other one would apply to the guess itself. It has to be two different arrays. Using one single array is not going to do it. Okay, so this will be the same length as pattern length. And obviously we got a case issue here. So, okay, so now that we have the two arrays, the first thing we need to do is to initialize these arrays because they come uninitialized. So we'll just go ahead and use a fairly short loop to do it. And the initialization is just hidden matched bracket I get 0 because it's not matched. Nothing is matched until we run the actual algorithm. And guess matched bracket I is also a 0. So the initialization is done. From line 21 to line 25 is the initialization of the two local variables, each one being an array. Are there any questions at this point? Yep.
So 0 is never going to be a potential number we use?
Well, actually, that's not how this is represented. If it is a 0, it means that particular peg has not been matched. If it is a non-zero, it means it has been matched already.
Oh, okay.
So it's just, it's a convention. It's up to you. You can use a different convention. All right. So the first thing we need to do is, okay, you cannot use one single loop to do both the black pegs and the white pegs. You have to match the black pegs first, and then use a different loop to match the white pegs, because otherwise it does not work out. The matching of the pegs can interfere with each other. Okay? Unless you use some special logic in your code, then you might be able to pull it off, but I would just separate it into two different loops and not to get into that problem. So the first thing I would do, okay, not saying this is the only way to do it, but this is how I would do it, is to use a single loop to figure out the number of black pegs first. And to do this, before this, I'm going to change the number of black pegs all the way to 0 because it's acting as a counter. So I use PG to get to the structure pointed to by PG, and then I will say, score black pegs equals to 0. I reset it to 0 first. And then in this loop here, yep.
On line 27, did you forget to put the I at the end?
Oh, equal to 0 is not here. Correct. And same way.
You also forgot to put plus plus I. You just put plus plus.
That one is easy. The compiler will definitely figure that one out. There we go. Thank you. All right, so in the loop here, which means for each position, I want to do the following. You can use a loop to do. You can use a conditional statement to do it. You can use a ternary expression to do it. Either way is fine. So the way to do it is to basically say, if hidden bracket I is the same as pg dot pattern bracket I. If this is matching, then we'll go ahead and do one little thing here, which is just incrementing the counter called score black pegs. You can use post increment here. It will do the same thing. It doesn't really matter because no one is making use of the value of the expression. We are only relying on the side effect to change the number up by 1. Are we still doing okay so far with this code? At the end of today's session, I will save the file and upload it to Moodle. So if your intention is to use my code to start off with your homework assignment, there's no need to do frantic copying. You just have to you just have to remind me to upload it at the end of today's session. Okay, that's all you need to do. Barring any type of power failure and other types of catastrophic technical difficulties. Well, don't forget Murphy's Law. All right, so this should take care of all the black pegs. So the next thing to do is to take off the white pegs. Oh, I forgot one thing. What did I forget to do?
Mark the array.
Mark it, exactly. So we have to say hidden matched bracket I is 1. Any non-zero would do. Okay, I'm just going to pick 1 as a non-zero. But we also have to do it to the other one, which is guess matched I is 1. So this way I remember in each pattern, this particular peg is matched already. Do not match it again. Is that okay? It's the idea that is more important. The syntax, yeah, if the syntax is wrong, it's not going to compile. So the next thing we do is to deal with the number of white pegs. First thing to do is to reset it back to 0. Then we're going to use a double loop to do it. So for int I equal to 0, I think I'm going to spell out this way so it doesn't wrap around the line. I is less than pattern length, and plus 5 at the end here. So this way it's not going to wrap around the line, which is making it harder to read. And then without even doing anything else, okay, I'm going to do it here. This is not efficient, okay, because if this peg is already matched, it's just going to waste cycles. But the code is easier to read this way. Okay, so I'm just going to do it this way. You can choose to do it in a more efficient way, but I'm just going to do it this way. It's supposed to be J. All right. So at this point on line 45, I would have I as an index to control index into one of the patterns, and then we'll have J as an index into the other array. Okay, which one is for which one? Which one that you want to use with hidden, and which one you want to use for guess is entirely up to you. Okay, it doesn't really matter whether you use I or J for which one. You just have to pick one. Okay, so here's the most important part, which is the expression to basically say, okay, am I even going to try to match? Okay. So this is going to be one long expression. I'll just do it this way. Because the expression itself is going to be a little bit long, so I'm going to do it in a nested fashion. The first one is, I better make sure this position is not matched from, in the hidden part, okay? The first one is to say, okay, this is the first one. First one is I should not be the same as J. Because if I is the same as J, that would have accounted for already when we computed the number of black pegs. Is that okay? Because I use one to control the indexing into hidden and the other one to index into guess. If they are the same, I would have taken care of this already. There's no need to reconsider this. So we'll just guard it first. It is not necessary, okay, because the other conditions would have caught this one as well. Then we'll say it is not matched yet. Okay, so I'm going to use I for hidden. So this is basically saying it is not matched from the hidden pattern. Well, since I'm just going to make it more efficient, might as well just take that away. This one is for guess, and it will use the other index, which is j. So this is basically saying, okay, the element in hidden at index I has not been matched. The peg of guess at index j has not been matched yet either. Okay. If they are the same, would it matter? I'm just thinking whether this would make any difference or not. Putting it here definitely would not hurt, not equal to. If I have to make sure I does not equal to j. So I'm just going to put it here. Okay. So at this point, by the time I get to line 49, if it matches all of these conditions, it means I does not equal to j. They're not at the same position, and neither pattern has this particular peg matched yet. So now I can actually do the actual comparison and say, are they actually the same? So ampersand, ampersand, this is going to be the last one, which is hidden, bracket I, does it equal to pg dot pattern, bracket j. That is the last condition I need to check is, are they the same? If they are the same, I got a few things to do. The first one is to increment the number of white pegs, which is pg points to score white pegs. So I need to increment the counter by 1. And then the second and third thing we have to do is to remember these things are now matched. Do not match them again in the future. So we have to say hidden matched bracket I is now a 1. And guess matched at bracket j is also a 1 because that particular peg is now matched. Are we still doing okay so far with this code? Okay, all right. So I think we're done. So save it. And we have need to do a 1 pound include here, which is standard I/O, because the scanf and the printf requires stdio. We also need to pound include mm.h, which defines the structure and the constants. Yep, go ahead.
Why is it that sometimes when you include, you have like the exclamation points? Sometimes you have a little.
That's a good question. Double quote means it is in the folder where the rest of the source files are located. And then the angle brackets means it is a system file, so who knows where it is, but it should be there somewhere. Okay. All right, so, yep, go ahead.
If you did use the system file for your ones that's in the folder, would it still find it? Like, does that say like?
If you have your own stdio.h and you say double quote stdio.h, it will find it. And it will consider your standard io.h to be different from the system stdio.h, which makes it confusing. Confusing to you or the developer, but not so confusing to the compiler. All right, so I think we're done here. And somebody taught me XA will save and exit all. So that's why it's nice because we can get out of the editor without having to quit each file individually. So now I have everything. We'll just say make, cross fingers. Hey, that seems to compile. All right, so the first thing we have to do is to give it a hidden pattern. And what do you guys want to use? Give me something tricky. The trick here is the test case of yours.
0440.
Okay, 0440. And what do you want to specify as the guess pattern?
4 is on the bottom, not on the top.
Say again?
Use 3 4s. Doesn't matter. We should order.
3 4s.
At
Okay.
least 3. Yeah.
So 4 4 1 4 maybe. Okay. So before you run the program, you need to figure out by hand manually what the program is supposed to print, because otherwise you just look at the numbers and go like, oh, that seems right to me, right? Okay. So if you just run this through by hand, how many black pegs should we get? 1. How many white pegs should we get? Also 1. Okay, very good. So it should be 1 and 1.
1.
And it says 1 and 1. Perfect. And okay, let's test with some boundary cases, okay, where we have this as the hidden pattern and this as the actual guess. Okay, 0, 0, pretty clear cut, not a problem. We'll give it some cases like this, and it gives us 4, 0, which is correct. Okay. Are there any other test cases you guys want to run this through? I mean, come on, try to break my program. Go.
1, 2, 3, 4, 4, 3,
B, B, B.
Okay, go ahead.
1, 2, 3, 4, 4, 3, 2, 1.
Okay, so what should be the number of black pegs in this case? 0. What should be the number of white pegs? 4.
I do have a question on your code. I actually did the exact same code, except you did that one line where you said I does not equal j.
Uh-huh.
I didn't do that.
That should not be necessary.
Okay, that's
Yeah,
fine.
that should not be necessary because anything that has matched both color and position would have marked so anyway.
Yeah.
Yeah.
Okay.
But I was, going like, well, maybe. I know it wouldn't hurt, so I just kind of stash it there since it's not going to hurt. Any other questions? Do you think you can get a job if you are really good at breaking programs? If you have a special knack of saying, okay, I know this is the specification, but I'm really good at not following the specification and see what your program is going to do when I do not follow the specification, do you think you can get a good job because of that special talent of breaking things? The answer is absolutely yes. And that is basically an entry point requirement to become a good hacker too. Yep.
I know Google, I think, pays about $5,000 for clients problems like that. Their codes.
I would not be surprised because to Google, being able to quickly identify a problem and get it fixed is worth a whole lot more than $5,000 because it could have costed Google easily millions of bucks depending on the nature of the bug.
They're just cheap, that's all they pay.
They are cheap. $5,000 per bug is cheap, actually. Yep. But to most people, it's like, wow, cool, $5,000. All right. So, are there any questions about the program? I want you guys to kind of focus on the actual code and see if you have any questions about it. Because if you do, this is a good time to ask. Yes.
I just have a theoretical question.
Go ahead.
Saying, is it possible not to use the arrays?
How to use arrays?
Like you said, it's possible to not use the arrays. I just wanted to get an idea of how to
Correct.
do it.
Okay. The other approach not to use 2 arrays is not really recommended because what you're going to do is, in order to remember something has been matched already, so instead of doing this on line 34, I'm just going to put it here, but it's not recommended. Okay. So I'm just going to put it in comments so it's not accidentally put into the actual code. So the other way to do this is to say, hidden bracket I gets a value that should not be a color. So I can pick -1 here. Now, if you use this approach, you have to be extremely careful because the value that you put into guess as an invalid value has to be something different than -1. Otherwise, -1 can match -1. And then you have to change the code later on to also specify if it is not within the range of 0 to 5 in this case, do not consider it because it means it has been matched already. Actually, you don't have to specify anything like that. It simplifies the code a little bit, but you will end up destroying guess E also because you will basically end up with a code that looks like this. PG dot pattern bracket I equals -2. But if you had done that, that would have destroyed the actual guess pattern. Then it won't work well for our next homework assignment, where you are the one hiding the pattern and the computer is the one guessing it. And when you're doing this, okay, let's think about the next homework assignment, just so that your mind is already going to slow cook it for a little bit. What if you give the computer the wrong feedback? When you are supposed to say blah blah blah, you gave it the wrong feedback. What do you think the computer eventually will figure out? It will. No. The computer will go through all the way from 0, 0, 0, 0 to 5555. None of the patterns is matching the history of the guesses. What do you think the computer should conclude at that point? You're cheating, exactly. The computer can tell that you are actually cheating because you are giving it inconsistent feedback that is impossible. Okay, that's one of the conditions that your next homework assignment will have to detect. It's actually not that hard. I mean,
They have to detect the cheat code.
Yep. The generate and test thing, do you think the generate and test thing is going to be easy to do or difficult to do?
It's gonna be written down.
Okay, how about I show you how to do it right now? How to generate the pattern all the way from 0 to 5555. You can do it with loops, okay? But if you do it in nested loops, it's not going to work when I say I'm going to specify a different length of pattern. Because I know someone is going to think, oh, I just need 4 nested loops, okay? The outermost loop to control the first peg, the second loop, nested one controls the second peg, and so on. But what if I change the number of pegs in the pattern? It's not going to work. So the way to make this work, even if I change the number of pegs, even if I do it on the fly, it will still work, okay? Is to do it like this. I'm just going to say generate.cpp. Okay, is to do it recursively. Okay, so to do this recursively, this is how you do it. You say void gen, and we'll say position here, and then you basically specify a particular number. Okay, so you have to keep track of your own number, which starts with 0. Equals to 0, and then you have to say if position is greater than 0, you do one thing here, else you do something else. This is a general pattern of recursion, is you have to have a condition to detect when to call itself again and when to stop calling itself. So if you do need to do a recursion, you're going to call gen again, but this time when you call gen, you will have to pass position -1, because this is the only way where position will get smaller and smaller and eventually get to 0, so you will stop the recursion. Otherwise, it will keep going and going, and it's not going to be helpful. Okay. All right. So getting back to this one here, this one cannot be just that. It has to be a loop. So I'm going to have to say for I equal to 0, I is less than, I don't know. We can make it 7. And put everything else in a loop. And I have to indent all of this stuff here. Go. All right. So this one is no longer necessary. All right. So the question now is, what if position gets down to 0? There's no one to call anymore because we have the entire pattern at that point. So what we'll do is we'll just say, give me a line feed, and also the value of I at that point. Is that going to work? That won't work because I'm not holding the entire pattern, because it will just, yeah, that's not going to work because it doesn't know the pattern up to that point, which is a problem. Okay. So it needs an array to begin with too. So there we go. we'll print the entire pattern here. So I is 0, I is, we need to know the actual number of positions. All right, so we have 3 arguments or 3 parameters. The first parameter is an array, okay, because we need to use some mechanism to store the values of each position. And that's going to be patterned as the array, as the first parameter. The second one is which position of the entire pattern am I responsible for, this particular invocation. The third argument, which is length, is the actual length of the entire array. How many elements are there actually in the entire array? So I'm basically saying this is the array, this is the position that I'm responsible for, the index that I'm responsible for, and this is the actual full length of the entire array. Is that okay? That's the input into the subroutine. So in the subroutine, what I do is of the position that I am responsible for, assuming that there is one that I'm responsible for, I'm just going to go from 0 to 6 in this case. So go from 0, 1, 2, 3, 4, 5, 6 for each iteration. And then for each iteration, I'm going to say, am I already at the end of the entire array? Is position the same thing as length? And if, so let's see, when do I stop recursion? When I stop recursion, it is when position is the same thing as length. So that way, I'm determining when I should stop here. Okay, this should be when position is less than length minus 1. It has to be like this because this is the time when I still have one more position to determine. Because I'm responsible for the second last character or the second last entry of the array in this case. So there's one more position that we need to deal with. So I'm just saying, well, given the value that I have at this point, go to the next invocation to take care of the last position. Now, on the other hand, when position is no longer less than length minus 1, which means it is length minus 1, that means I'm the one responsible for the last position already. If all the positions are specified at this point, there's nothing else to do. All I'm going to do is to print out all the values of all the positions, which is what the else is doing. So the else is basically going from I going to 0 all the way to length minus 1, and it will just print out each position without a line feed, and then append a line feed all the way at the end. You can see the line 15 is outside of the loop. So this will basically generate all the patterns from 0, 0, 0, 0 to 0, in this case, to 6, 6, 6, 6. Okay? And the way to do this is to make use of this is to make a main function here. In main function, I have to allocate an array for pattern. So we'll just say that pattern has exactly 4 elements, and then we'll make a call to generate. And the first thing we pass is pattern. Second one is which position is this invocation responsible for? We have to start with a 0. And the actual length of the array is 4. There are 4 elements in this array. And that's the entire program. This is going to generate, okay? Well, we don't know whether it works or not, so we'll go ahead and test it. Yep, go ahead.
Yeah. I was saying can we test it?
Yep. You don't want to trust my code if it's not compiled and run. And we can definitely see there are problems here. Okay. Nodes not declared here. Okay, fine. Line 7, line 13. Okay, I got it. Okay, first thing is I did not pound include stdio.h. Whenever it complains about scanf and printf not declared, that's because I did not pound include the right header file. So that's an easy one to fix. The other one, which is the recursive call, Can anyone tell me why line 9 is having a problem? How many parameters should I pass? 3. How many am I passing here? 2. That's why. So the last one is missing, which is the length of the entire array. All right, let's do it again.
This is how we generate.
This is how to generate. This is this part here. Yep.
Now you can increase the array.
Sorry?
Now you can increase the array.
Ah, to make the array bigger?
Thank you.
To make the array bigger, it's all done in main. So you basically have to change this number here. So if you want to play with this, you might want to consider constant length. Make it 6 if you want to. 40. Fine.
Okay.
And we can sit here and just let it crunch, since I'm not paying for the computation time anyway. But you can see how it's moving up, right? I mean, it's just generating all the possible patterns, given that for each position it goes from 0 to 6. Are we doing okay so far for this? I just stopped it. It didn't break. It did not crash. Just did a Control C.
I would think it would go faster than that.
It's slow only because of the printing. It's only because we are printing. If I were to capture this into a file, it goes a lot faster. Yeah, because the scrolling of the screen and all kinds of stuff like that takes up actually more time than storing the patterns into a file. There was another question. Another hand? No? Okay. Any other questions about this part? You can see how this approach is better than nested loops, because if you do it with nested loops, you cannot change the number of, you cannot change the length of a pattern easily and still have the program work correctly. Yep.
So you tell the program that after how many tries, you should give me the right answer.
Say again?
You tell the program that after how many tries, you give me the right answer.
Not sure what
Maximum
you.
amount of guesses?
Yeah.
Well, if I were to turn this into the actual program, to play Mastermind, what I need to do is, instead of just printing the actual pattern, I would have to check it with all the current guesses, all the guesses already stored in game as a structure, and see if this is the hidden pattern, would it have given me the number of black text and the number of white text for each guess that is already logged in game. If it does, on the first one, I'll just say, we'll pick this one as the next guess. It is not optimal. There is actually a way to make it more optimal, but as far as we are concerned, this is good enough. So that's how it works. That's why we want to keep track of game is so that we can set it up for the next stage.
Yes.
So we'll basically be reusing score, because in the case of this particular program, this pattern is going to be the hidden pattern for score. And then we'll basically be cross-checking each guess that is already logged and make sure that it does give us the same number of white text and the same number of black text. If it does not, we move on to the next one, because it is inconsistent. This cannot be the actual hidden pattern. Now, if you want to make this more optimal, you can actually create, if your computer has enough memory, you can actually allocate just 1 bit per possible pattern and indicate whether it can be the answer or not. So you can skip through the ones that cannot be the answer and just go straight to the next one that possibly can be the answer. But if processing time is not a big deal, you can just regenerate and retest everything from scratch each time. So do you guys get a general idea of what the program is going to do? It's called a generate and test approach, which is a fairly common technique in AI and now also in computer security. AI is artificial intelligence. It's just brute forcing it. Okay, any other questions?
So this
Yep.
would be something you would use for the next assignment at the moment?
This would be one part of the homework assignment. The other part would be going through all the stored guesses in game and see if you can come up with the same number of white packs and number of black packs, which is actually not very difficult. It's just a loop, and you can exit early. As soon as you find one that does not match, you can exit. Are there any questions about the solution of the homework assignment that was due today? Was it close to how you guys did it, or this is like completely different, man? A little different? A little different is okay. There are different ways to do it.
But you get the same result.
You get the same result, yes. Now, the next question is, if I change mm.h to have a different different length, would your code work correctly too? Okay. In other words, the big question is, when you look at the way I did mm.cpp, did I refer to 4 anywhere in this code? Did I refer to the number of colors as a number anywhere? That means this particular program is flexible. This code is flexible because if I change the definitions in mm.h, it will just use the new definitions and it will still work correctly. Okay. All right. Well, that's the end of the structured lab portion. Yep.
Can you go to the last one?
The last
few lines?
the last few lines of
For the upload the whole thing.
upload the code. That is important. Let me do that first.
Yeah. Pretty similar. I did the second that too, right? Yeah. Just how you did it. Yeah. So like, first I was like, I tried to work on it. It's like, wait, so it's like that. Yes. We start the assignment. So for MMs, how do you call your
That's pretty much what we know.
Okay, so you want me to go through the last few lines of the code?
Yeah, but
MM score. Okay. Which part? Okay, can you make your question more specific? Like which line? What about that line that you need to ask about? Say again? Line 58 to line 60. Well, line 58 increments the counter. The next two lines indicate that those positions have been matched already.
So, but syntactically, it would just so what I should write down is
The purpose of the array is to remember
No.
whether those
It just kind of makes me happy.
and now that I have matched them, I have the indicator Yep. Okay. Let me stop the recorder first.
and so since wait, after generating things and then